This
We are
conference will now be recorded.
Sorry?
he's not joining today, Gopi.
Okay. So you were just waiting for me?
Yeah.
Sorry.
So did you try that yesterday EC2 part?
Sorry?
Did you try it yesterday EC2?
No, not after the class.
No, no. Oh, okay. Just try a little bit. The more
Yeah,
you explore, it will be easy for you.
this is not, it's very difficult. That's the problem.
Yeah.
Get
Okay,
back
fine.
late. Get back late, and by the time I finish my, it's almost already class time.
Yeah, but you have Friday, Saturday, Sunday, 3 days. You can try. No issues. Okay. So can you see my screen?
Yes.
Yeah. So what I have done today, we will see first EBS, then load balancer, then auto scaling. So as of now, what I have done, I have just created two EC2 instances. Okay. And in that there is nothing. It's just a plain EC2 instances. And both are in the same availability zone. That is AP South 1A and AP South 1A. Okay. So what we will do first, when I was trying to create this EC2 machine, I have this 8 GB of volume by default attached. Now we will attach one more 10 GB of volume to the server 1, and we will insert some data, and then we will detach that volume from the server 1 and will attach to the server 2. Because AWS EBS volumes are persistent volume storage, so that we should be able to do that. And the data should be persist from when we attach one instance, add some data, and then detach and attach to another instance. It should work. So let's start today's session. So I have two server ready, server 1 and server 2. Both are just a server, nothing installed in that. Then let's go to the volume section, and from the left hand pane, volumes. And here you can see the 8 GB of volume, which is attached to your EC2 instance whenever you create an EC2 instance. Okay. So at that time, whenever we configure in the EC2 part, we have this option 8 GB of volume, 8 GB of volume. Can you just tell me once again, like what are the steps that we have involved yesterday while creating the EC2 instance? Just a small recap. Hello?
Yeah. Sorry. You was in mute.
Yeah, it's okay.
Yeah.
So can you just tell me what are the steps involved in creating an EC2 instance yesterday? Just a quick recap.
No, I had to refresh my.
Okay, so what we done, we have first selected an AMI, correct? Then when you click on next, it asks you for the processor, that is instance type. We have choose T2 micro, and then we have configured the networking part, which VPC, which subnet, and what are the other configuration you want to do. Once it is done, then you attach a security group, then you attach an EBS volume, that is root volume, and then you add tags and then launch your EC2 instance. So whenever we attach that 8 GB of volume, that 8 GB of volume, you can see here, that is server 1 and server 2 basically. And this is the 8 GB of volume. Now what we will do, we'll create one more volume of 10 GB. Click on create volume, and you can create a volume from minimum 1 GB to maximum 16 terabyte. We'll go with the 10 GB. In your free tier, you only allowed to have 30 GB of volume per month. So make sure you use it wisely. Okay. And the availability zone. Our both the EC2 instances are in AP South 1, so we will not change that. And we'll keep everything default. And let's go and create this volume. Okay. So this volume is being creating now. It will take few seconds. Okay. It's now available. Let's name it as mm, extra volume of 10 GB size. To attach that volume, you need to just click on simply action and attach volume. Okay, now here is a few points like you can modify a volume. Okay, modify a volume is like you can upgrade that volume size from 10 to 20, from 30. But if you try to come at the lower side, that if you try to decrease that size, it will throw you an error, because storage volumes cannot be decreased, it always be increased. So in case, let's assume that currently you have 10 GB of volume, and tomorrow you want to upgrade it to another 10 GB of volume. So in that case, what would the good solution? Either moving or no, even modifying that existing volume, or attaching that another 10 GB of volume. What do you think? What would be a better solution?
Attaching another volume.
Exactly, because what will happen if you modify this existing volume, and in case in the future if you want to go back to the 10 GB of volume, then you don't have that option. So the best practices says you should attach multiple EBS volume, so that at any time if you want to just cut off that volume, you can easily delete that the extra volume. Okay, so it's one of the best practice. It's called horizontal scaling, and whenever you upgrade the existing volume, that's called vertical scaling. Okay, so in this way you can modify, and to attach that volume you have to simply click on action, attach volume, and in the instance, whenever you click, you will get to both of the instances running. So let's attach to the server 1, that is instance ID server 1 running, and click on attach. That's it. Now to check whether it is attached or not, just copy this public IP of server 1, log into your EC2 instance, ssh-i key pair and ec2-user at the rate public IP. Yes, connect. So unprotected. So I have to do chmod either, or there is another file available. Okay, I have logged in. Let's clear this. Now, if you do first of all sudo su, now to check whether the how many block storage you have attached to your EC2 instance, the command is lsblk, list block. So you can find there is a one XVDA. In that XVDA, there is a one that is 8 GB of volume, which is mounted to slash, that is root device. Okay, so this is your default root device which is mounted on the root. The another is that you have just attached, that is 10 GB of volume. You can see here. Now you can see the same description in the AWS console. If you just scroll a little bit, you will find here there is a root device XVDA, and there is one more block device that you have attached, that is dev SDF. This is for the server 1, but if you see on the server 2, you will not find any other block devices. So whenever you attach, and you will find here the block device that you have attached. Okay, this is one way, and that is another way. So in this SVDF that we have just attached, this is completely a new disk, right? We cannot just write the data directly to our that particular disk. What you need to do, you need to create a file system like XVD, like EST4, like there are different formats available for the disk. For Windows, it's NTFS, FAT32, etc., etc. So such kind of you need to create a file system. So the command is make file system mkfs -t, that define what kind of parameter you want to create. That is, I want to create a ext4 based format, and my location is /dev/svdf. Okay, this is svdf. So I want to format, I want to make the file system of this device, so xvdf, and hit enter. So lsplk, again it has created that file system. Now the second step is to create one file. The command is make directory mkdir, and let's create a one test folder ls. There is one test folder already created. Now what we'll do, we will mount this test folder to that disk. Command is mount /dev/xvdf and /txt lsplk again, and you will find that this 10 GB of volume is now attached and it is mounted to the test folder. Now whenever you want to enter to that 10 GB of volume, what you need to do, cd/test, and you are in your 10 GB of volume. Now to test our connection, what we'll do, we'll just simply create a sample file. Let's call text.txt, and here we will write something like this is just sample document. Okay, so if I just ls2, and you will find here txt.txt file has been successfully write to the test folder, which is in your 10 GB of volume. Correct? Now what we will do, we will unmount this directory from our instance 1 and we will attach it to instance 2. So the command to do is, but before that you need to just come out from your test folder because we are unremoving the test folder. So cd, okay. Now umount, the command to unmount is umount and mine -dev/xvdf. If you try to do now lsplk, you will find that the root mount, the mounting point is been unmounted. Now you have successfully unmounted that volume. The next step is to detach that volume. Okay. If you remember, if you see in Windows or in Mac system, whenever you attach a hard drive, you have an option to eject that volume, correct? So the ejecting part is like unmounting the drive. So we have just ejected that volume, but we need to unplug that volume from our instance 1 and attach it to instance 2. This is a part that we need to do on the AWS console level. So let's back to the AWS console, and in the volume section, this is the 10 GB of volume. What we will do, we will click on detach volume. Yes, detach. It's currently saying in use, but it will in a few seconds it will be available. Okay, it's now. And then back you have to click on action, attach volume, and now we should select server 2. That is, we are attaching to server 2. Attach. Let's go back to the database instance, and if you see the instance 2 description, here you will find another block device has been attached. Let's log into this EC2 instance. If you try to do lsblk now in your previous instance, then you will find that the volume device has been detached. Let's create one more, and ssh-i key pair is to user @ public IP of your second instance. Enter sudo su and lsplk. So we'll find that 10 GB of volume has been successfully attached. Now the thing is, in the first EC2 instance, we have created a file system, correct? But I don't think so that we should create one more file system, because the file system is already present in your volume. If you try to create one more file system again here, what will happen? The existing data will be lost. Okay, so if you want to format the drive, then only you should create a file system. Now we have already created a file system in the previous instance, and we have inserted some data in that volume. Now to check the data on this EC2 volume, we have to mount that directory. To mount that directory, the first step is to create a directory. Make directory, let's say this time volume. Okay, Now same command mount-dev/svdf/volume. And if you try to do lsplk, you will find this 10 GB of data has been successfully mounted. Here it was nothing, and here the volume has been successfully mounted. Now if I go back to the volume section, I must have that sample.txt file, that is text.txt file. Let's see, and here we go. The text.txt file that we have created in the first instance is available in the second instance, which means data persists whenever you detach and attach that volume. And it sounds like an hard disk drive that you usually do when in your local machine, like a pen drive, a 10 GB of pen drive. You attach to one machine and then detach and attach to another machine. Let's see what is there in the text.txt file. This is just a sample document. This is something that we have created, correct?
Mm-hmm.
Is it fine, or am I too speed?
No, that's fine. This looks like, EC2 is more completely operational for operations guys.
Yeah, basically it's a computing service, so you need to do it's like a more on commands and configuring the things. Whenever you go for the VPC, it will be more focused on the networking part. The VPC is completely networking part. For Route 53 is completely DNS part. Storage is completely storage part, S3 and all. So we need to focus more on commands here. Operational particles, exactly. So in this way, you can create EC2 instance and attach and detach volume in both the EC2 instance. But the thing is, yeah.
So what are the services more related to the development and data science kind of?
There are many services. We have EC2, we have Lysale, Elastic Beanstalk, Lambda, and
So we're
RDS.
those, right?
Sorry?
So we are going to be covering those, right?
Some of them.
Okay.
Because on AWS, there are more than 100 services are available. And we cannot cover everything in a short span of time. But whatever the required for the solution architect course, and we will cover, that will be required for highlight of the entire AWS infrastructure, what is computing, what is networking, we will cover all those.
Okay. Yeah. So most operations thing, at least for me, you can just go browse through it for just understanding. That's all. When it comes to more of data science and development side of it, help me go in little details.
Okay.
Okay.
So this is AWS EBS part. Now, if you see on the system check, there are two types of system check. First is system statuses and second is instance statuses. So whenever you see here 2x2 check, which means that is one is system check and second is instance check. A system check is something that defines whether the hardware part is working properly or not on Amazon data center. Okay, it's not about our instance, it's about AWS data center, that whether that instance, whether that rack of server, the storage and everything is working fine or not. And the second is the instance, that is the VM, the virtual machine that you have created, and the software and the networking part that you have attached to that instances is working fine or not. So probably whenever it says a 2x2 check, that is healthy, and whenever it goes 1x2 or 0x2, at that time you will find a little difficulty in accessing your EC2 instance. But that is a very rare case. You will not find it frequently. The third option is monitoring. Now, AWS CloudWatch monitors all the application in 5-minute interval. Okay, so basically, this will show you a few of this monitoring tool. If you want to have detailed monitoring for every 1 minute, then you can configure for the detailed monitoring, which cost you a little more. And here you can find different monitoring tools, that is CPU utilization, disk read, disk write operation, disk write, etc., etc. So all these things you can find it here. And the last thing is tags. Now, why we have all these tags in every AWS services? Like, tags plays a very important role when it comes to organizing your production account, organizing your test account, and it's also easy to search the exact resource from the list bunch of many resources. If you go for the professional level certification, there is a very deep concept on resource tagging. In the resource tagging, you will find you will configure the AWS resources based on the tags. So if there are many environments present in your existing AWS account, there is a huge number of production account servers available. There is huge amount of test servers available. So you can distribute all this into two different page, and you can just have a look more on the operational side, and more you can design it better. So this is also something that is at the professional level. But this is one of the best practices that you should attach tags. It's like commenting on your code. Whenever you write any kind of code, there's the best practices is that you should comment and write what exactly you are doing. In much similar way, this is something tag that gives you best practices of creating and tagging the things, whatever you are creating. Okay. Now let's look into load balancer. Okay, let's just see first the description of load balancer. So EC2 load balancer. An elastic load balancer automatically distributes incoming application traffic across multiple targets such as EC2 instance, container, or IP addresses. So just understand, like there are multiple EC2 instances running for your production account. There are 4, 5 EC2 instances running behind for your serving a single application. Now, whenever a request is coming from the internet, it should drive the traffic to all the EC2 instances, correct? This is a job done by the elastic load balancer. Now, elastic load balancer act as the front end of your web application or act as a single point of contact where you can hit your user, and this load balancer will distribute the traffic to multiple EC2 instances behind your infrastructure. It's like whenever user wants to hit your domain, that domain will be mapped to that ELB endpoint. So whenever I say I want to go to google.com, then that google.com will be passed to this ELB endpoint. And now this ELB will send the request to the multiple EC2 instances, whichever it is free. So for example, if 3 EC2 instances are configured behind a single ELB, then it will distribute that particular traffic among any of these EC2 instances. Let's say if EC2 instance 1 and 2 are busy, then it will send the traffic to the EC2 instance 3. Or based on the computing size available, based on the number of requests sent to each of these EC2 instances, it will send the traffic. Now the important point that you need to remember here is ELB works based on the round robin technique. A round robin technique is something which distributes the traffic equally. For example, if 3 incoming connections are, if 3 coming instances requests are coming, then it will send first request to EC2 1, then second, then third, and whatever the next fourth or fifth requests are coming, it will send back to the EC2 1, then EC2 2, then EC2 3. So it will distribute the traffic one after another to equally among all the different server. It will not like until the EC2 1 gets completely 100% utilized, it will send to EC2 2. So it will send the traffic equally. If 5 incoming connections are available and if there are 5 EC2 instances available, it will drive the traffic equally. Suppose now here 10 requests are coming. So first 5 will be served to all the EC2 instances, and then from 6 will be sent to the EC2 1, 7 will be EC2 2, third 8 will be to EC2 3, so on. So it drives the traffic equally. Now this is a 3-tier architecture. If you see from the left hand side, our design starts from the left hand side, that is incoming application traffic. So whatever the traffic is coming, it has been routed via Route 53. That is the DNS, the first logo that you see here. This is a Route 53.
Was on mute. Can you go back to the previous slide?
Yeah, sure.
Okay, so the first one is the round robin.
No, both of them are the round robin only. ELB supports round robin. So it doesn't matter there how many servers are available, it will drive the traffic equally to them.
Okay. Yeah, that's why I asked, because both look the same. So what is the difference?
Yeah, no, both are same only. Just a high spike of on the ELB, then what it will do. That's it.
Okay. Okay, go to the next one. 3-tier.
Now, if you see this first logo, this is the Route 53, that is JS, which is like your domain name system, example.com, whatever. So whenever the incoming connection comes to your domain, that domain will send the traffic to the ELB. So
You
this
said
is
that was the route.
Sorry.
The first box is the Route 53 or?
This is a Route 53, this small part. Okay. And this box is your entire AWS infrastructure. Okay. Now this is a 3-tier architecture, which means the first two subnets are public subnet, which means like your front end site, like Amazon.com, the whatever the things that you see on the front end is placed here in the public subnet. Then whatever the application logic you have created, that application server, the backend server will be situated in this private subnet, and the database that you have created for this data for this application will be situated again in the private subnet. Now the difference between public subnet and private subnet is, for a public subnet you attach an internet gateway and you get a public IP, that is auto assign public IP. We have seen that public IP you get in the public subnet. But in private subnet, you don't have internet connection, you don't have public subnet. And that's what make it private. So whatever the instance you are creating, that will be private. It's one of the best practices that you should create your infrastructure in a private subnet only. Even for the public subnet also, you can create a private instance. So this is one of the best practices that you need to follow in all the production account. In all the production, you will not have any public IP. But how to access then AWS services, how to connect to your EC2 instance via private IP, that we will see in the VPC section. Now here two things to remember. Whenever the requests are coming to the first ELB, this first ELB that is marked from the yellow arrow is treated as a front end, or it is treated as an internet gateway or internet facing ELB. Because the requests are coming from the internet, so it is internet facing ELB. But this ELB is not facing internet, because the incoming connections are coming from these two private subnets, or whatever the instances are created in this subnet. The requests are sending from this requests are coming from these two instances. So this kind of ELB is called as internal ELB. Whenever it is facing to the internet, it's called internet ELB, and whenever it's facing from the internal side, internal architecture, is called internal ELB. This one is also internal ELB. Let's assume what exactly ELB do. 3 incoming connections are coming to see the Amazon.com site or any Flipkart.com site. Okay, this connection has been routed from the Route 53 and sent to the ELB. Now, ELB will distribute the traffic equally to both of the EC2 instances and show the content, whatever the front end side available. If that guy has tried to purchase something like add to cart and then going for the cart and doing for the payment thing and all the things, so all the things, the backend configuration will be then sent to the via this ELB, and this ELB will send this traffic to this private subnet to process the request. So if that guy is trying to add your banking details or try to do payment or adding the address, everything. So these kind of things will be happen in here.
So basically anything non-PCI PI will happen in the public, and anything PCI PI will happen in private subnet.
Correct. So once it is created, that logic, once the request has been served, this institution will drive that the data to the database. So this is the basic idea of distributing the traffic between multiple instances.
So in the public subnet, only, so for example, only browsing and add to cart will happen.
Yeah.
Okay.
So whatever you want to show on the web server, the basic things, that will be a part of here. Now, whenever you click on add to cart, you also see from a page which all the description like payment gateway, payment details, and etc. These all the data will be still in the public subnet. But whatever the business logic is happening, if the guy has turned the quantity 1 to quantity 2 or 10, so this kind of logical is happening, that is the amount of that particular price into 10, amount of price into 2. So this is a basic example, but whatever the exactly transaction is happening, the banking side transaction is happening, this all will be done at the private subnet or private instance. The secured part is always happening at the private subnet. The business logic or the application server is always in the private subnet. This is a concept. So from this architecture, I just want to show you how this architecture work. And this is a theme that you need to configure, that you need to create in your production account. And the second thing I want to show is like the internet facing ELB and the external facing or the internal facing, internet facing and internal facing ELB. So with load balancer, you increases fault tolerance. That is, there will be a no position that your website is down or it's not sending the traffic to the particular EC2 instance, though it is ready, up and running. So it increases the fault tolerance capacity. It acts as a single point of contact. So let's assume that if there are two or more than servers are available, so how many servers, how many IP addresses you will map to your domain. But this, using this ELB, there will be a single point of ELB endpoint that you can directly attach to an ELB. So it doesn't matter whatever the number of servers you are running, it can be automatically driven by a single endpoint. Instances can be added or removed anytime. It performs health check. So there are different kinds of ELB available. We will see further in the next slide. But ELB gives you option to check the health of your EC2 instance. So for example, that index.html file that we have created, if that file is present or not, if that server is running or not, this ELB health check will perform. And the best part of the ELB is like, if your EC2 instance is in healthy, that is, it has a capacity to serve the request, then and then only it will send the traffic to that particular EC2 instance. If the EC2 instance is marked as unhealthy, that it will not send the traffic to that EC2 instance. Then it can be internal or external, that we have just seen, that is internet facing or internal. The communication between ELB and the instance take place through instance private IP and ELB. Now, the communication between the ELB and the instances are happening on the instance private IP. So it doesn't matter whatever the EC2 instance you are creating with a public IP is keep changing. If you just restart the server and if that the IP address changes, then also it doesn't matter, because both of these two AWS services are connected via the instance private IP, and that private IP will never change until you terminate that EC2 instance. Then ELB also has its own security group that you can define a broad set of security group. Like on the ELB side, you can define 80 port, which is open to the world. But on the EC2 side, you can define a security group with 22 open to your PC, and 80 is only allowed to the ELB endpoint. So yeah. Then it contains listener that checks the request. So it has also a listener that defines who can request to this ELB. If a request is coming from the 80 port, that is HTTP or HTTPS, then only this load balancer will serve the request. From any other port, if any kind of connection is happening, then it will not serve the request. So this kind of things also you can do. And ELB currently supports only 4 types of protocols, that is HTTP, HTTPS, TCS, and SSL. So there are 3 types of load balancer. The first is application load balancer, second is network load balancer, and third is classic load balancer. So classic load balancer is a previous generation load balancer. When AWS launched this ELB, at that time it was a classic load balancer only. And as it was moving ahead with the development and all the things, the two new load balancer was introduced in, I guess, late 17 or early 18. That is application load balancer and network load balancer. The difference between the application, the load balance, and network load balancer is like, if you know OSI model, do you know what is exactly OSI model? You might have studied in this college days.
No, man.
Okay, so there are 7 layers in the OSI layer which define where your packet is been sending. Whatever the request you do, whatever the data you send is been going through 7 different layers. So there is a network layer in between that, and there is an application layer. So application layer stands at the last layer, and network layer stands at the third or fourth, in between third and fourth layer. The future of the application load balancer is you can perform the health check, like whether that index.html file is present or not. It will check the request and then it will send the traffic. An application load balancer only support HTTP and HTTPS based requests. You cannot add any other protocol. Whereas in the network load balancer, it supports all the TCP from 0 to 65,000. Any kind of application, any kind of protocol you can attach. The other thing is it doesn't support health check. So you cannot just write an index.html file. Now, where you should go for the network load balancer? Just consider a scenario you have created a server for your mobile application. Okay. Now, whenever this gaming application, let's assume that there is a game development app we have designed, and that game development app is trying to access the server at certain protocol, at certain IP. Of course, we do not play the game at HTTP or HTTPS, right? We play game at a specific port. Now, from mobile application to the server, you can interact via this network load balancer. So whenever you do not perform any actions on the HTTP or HTTPS, now you can go with the network load balancer. And the classic load balancer supports all type of protocol, that is HTTP, HTTPS, and TPS. It's a previous generation that supports all. Now, when it comes to the performance and the efficiency, application load balancer and network load balancer support millions of requests per second. You can hit millions of requests per second, whereas the classic load balancer doesn't support that much future as it is previous generation load balancer. So from the performance wise also, application load balancer and network load balancer is a good practice to go. I don't think so this classic load balancer will go another for the next 1 year. They will terminate this action. Now health check terms. So what are the parameters from where you can define the health check? First is sprint protocol, that is protocol. Resource timeout, that is the time to live after how many seconds. If I'm requesting for something, if how many seconds I should consider as the response timeout. Ping port, that is at what port, 80 port, 443 port, 22 port, etc. Health check interval, after what interval this kind of health check should repeat. Ping path, that is for the application load balancer, that is index.html, the location of that file that you can define. And healthy threshold, that is number of consecutive successful health check. So let's say I have configured health check as 2. So what will happen? It will send the traffic to my web server and check whether that index.html is present or not. Okay. If this pass, if that test is passed, yeah, the health check.index.html document is present and is working fine. Then what it will do? It will wait for the another interval, that is health check interval. If the health check interval is set to the 10 second, then it will wait for the another 10 second and it will again pass a test. So at the time after 10 seconds, if again the the index.html is passed, that is present, and the instance is healthy, then this healthy threshold will be considered as a true, and then your EC2 instance become healthy, and then ELB will send a traffic to that EC2 instance. The same as unhealthy threshold, the number of consecutive failed health check. So number of failed health check pass versus number of health check failed. This is something unhealthy and healthy threshold. So that's just an overview of ELB. Now you can also create your own custom ELB on AWS. There is a one service called HA Proxy, which is a third-party tool you can just download in your EC2 instance and you can configure by sending into multiple EC2 instances. But the drawback of that going to the manual is like whenever a new EC2 instance come, you need to configure it yourself. Okay, but whereas ELB is Amazon managed services. Okay, so whatever the new EC2 instance coming or going, it will automatically do the relationship. It will automatically attach that into that group and it will automatically remove that. Okay, but in case you are going for the manual one, you need to do all these things at your side. So this is just a difference between going to the manual and going to the. Now one more thing is, if the traffic is increasing, then you have to attach one more load balancer here. If that EC2 instance cannot serve that much of load balancing, then you need to create two more load balancer. So it's not a feasible solution. Whereas Amazon ELB is a managed services, which means if millions of trillions of requests are coming, then it will automatically scale and meet the requirement. So here you don't need to worry about anything. You need to just focus on your product. Everything will be taken care by the AWS itself. So any question, any doubt in the ELB section?
No.
Okay. So I'm back to my this AWS console, and in this AWS instance 1 and 2, I have configured one PHP page, one HTML document. Let's just copy this and show you. So the first EC2 instance says that this is web server 1, and the second one says this is web server 2. Now we will try to create one ELB and we will throw the request to each of this ELB point. So if you just scroll down from the left pane, there is the option of load balancing. You can click on load balancer. Okay, and simply hit on create load balancer. And here you will find all these three types of load balancer. Let's go with the application load balancer. Create. Name the load balancer demo. And here you can choose whether it is internet facing or it's internal. Then what kind of listener do you want? That is, by default we have only HTTP and HTTPS, as we don't have any certificate, so we will go with this HTTP. And the second condition of application load balancer is an application load balancer should have at least 2 availability zone. So if I just try to click on one availability zone and try to configure the second, it will throw me error. At least 2 subnets is required. Whereas in the networking secret network load balancer, you don't have such restriction. Even with a single subnet, you can go. So this is something that you need to remember. Next, configure security group. Like if you have any existing security group, then you can select like this one that we have created last time, security group 01. I will go with that. Next, routing. Now here you are creating a group that will be considered as a unit for the front end, let's say for the front end, for the back end, etc. So let's say demo target group. And what are our target type? That is, our target type is instance, and we'll keep everything default. And here we will send a path to index.html. Now, healthy threshold, let's say 2, unhealthy threshold 2, timeout, let's say 3 is acceptable. Yeah, interval in every 5 seconds. This is to get a faster result. I have just configured this. Then register target. So what are the it's available in both the availability zone. You'll find it here. The number of EC2 instances running.
Hey Lalit, I can't hear you.
Yeah. Yeah, I'm just on mute for a second. It's actually loading.
Oh, okay.
Yeah.
You're actually breaking up also.
Yeah. So here we select both the EC2 instances like server and server 2 and click on add register. Okay. So these both servers are not registered. Click on next, review and create. Now it will take few seconds to create a load balancer and check whether the EC2 instance health check and perform all the things. Fail to create load balancer. There is something is mistake in the review. There is something missing in the target group. What is wrong? Both the instances we have attacked. Next review. Okay, now we have successfully created the load balancer. Refresh, and here we start. So currently, if you see the state, it is provisioning. We need to wait for another few seconds to come it as available. And this is your DNS endpoint, so which is like a single endpoint to hit your both the EC2 instance. We have two different IP address for the EC2 instance, but this will act as a single point of contact where you can hit to both the EC2 instance. So we have created a load balancer and a target group. Let's go to the target group and see how our healthy threshold is coming up. So this is the one that we have created just now. You see the target health check. Targets. Okay, so the current status of this target is initializing. That is, target registration is in process. So we need to wait for a few more seconds here to come as a consider as a healthy or unhealthy. So now you can see this both the EC2 instances are saying healthy, correct? Let's go back to the load balancer, copy this DNS endpoint and just hit to the website. Here it says this is web server 1. If I refresh this, it says this is web server 2. Again 1, 2, 1, 2. So based on the round robin technique, it is distributed the traffic equally to both the subnets. Okay. I'm sharing this link with you. You can try on your browser also. Can you please check that link?
Lalit?
Yeah.
You asked me to take the link?
Yeah. Just test that link. Go, just click on that link and see on the browser what you see. Is it working for both the EC2 instance or not?
Okay, hold on. I need help from my wife for typing. Hold on.
Okay, sure.
Lalit, let's do it tomorrow.
Okay. I have also shared the batch script with you. You can use this batch script to run your EC2 instance.
I'm sorry. Can you repeat that?
On the chat itself, I have also shared an bash script. So while creating that EC2 instance, you can use this bash script to create your Apache server and create an index.html file directly.
Okay.
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 So one more thing, that make sure you delete both the EC2 instance and the load balancer once you are done with your practicals. Okay.
Okay.
Okay then. See you tomorrow.
Okay. Thank you.
Yeah. Bye.